thankfully it did not record that. Anyway, what a lot of you all missed was an excellent question as we went to lunch.
Good thought. I really like this.
Let me get that a little bit better. Okay. Before we went to lunch, Peach asked a very good question. Do you know, just looking at this, that it's going to have a hole versus an asymptote? No. Now, I graphed it, and I did know that, and if you graph this on your TI-84 or whatever, you might not be able to see that hole. This was graphed from another program. But the fact that it wasn't doing this, like the asymptotic behavior, then I was like, well, there's got to be a hole there. Because I know I either had to graph it. I'm going to do a piecewise function in a minute, and you'll be like, what?
Infinite,
yeah.
Infinite limits. When do you get those?
We are going to talk a little bit about that today and more on Wednesday.
Is that like y equals, what's the one? 1 over x squared as x
Correct.
0.
Correct. Yeah.
So you
Yes.
cannot place a limit upon any function?
Yes, I can be asked to find the limit of any function at any point. By the way, if I had been asked for the limit as x approaches 2, then all I need to do is plug in 2, and that would be my limit. Because it wouldn't have done anything freaky with the bottom giving us a 0, And yes, I'm still going to do the same kind of thing with a lot of different functions. Aiden?
I was going to ask if, giving an asymptote there, would that affect the interval? How would it change that? How would you, I guess, figure out the area if it's...
If it's infinite? That's a really good question, and that's for later on. Trust me. But yes, infinite area is a thing. As something approaches the y equals 0, it approaches the axis. Yes, you can find that infinite area because it converges to a certain value. And you can do that. That's honestly for from a year from now. Okay. But I promise I will teach you how to do that.
Are you going to teach us how to evaluate indeterminates?
Certain ones, yes. Actually, my year 2 class did on Tuesday, I guess, the limit of certain indeterminate functions of the form 0 over 0 or infinity over infinity, and can evaluate those using some higher level stuff. Okay, but we'll do that. So there's 3 different ways you can do how you can find the value of a limit. Okay, when I did this is very analytic. Start with just plugging in the freaking number and see what happens. Okay, because if you get 7, then your limit is equal to 7. If you get an indeterminate form, then analytically, you could, like we talked about before, look at a table or plug in the value of something that is just to the left of 9, which is 8.9999999. And this honestly, even without plugging that into my calculator, because I've done the algebra and I've looked at the graph, I can tell you that is going to be equal to 5.99. I may be off by the millionth place, but yeah. So analytically, that is totally fine. This is the order in which I go. All right. I look at it analytically. I plug a number in. If I get 0 over 0, then I play with it algebraically. Multiply by the conjugate. Factor and cancel. Other stuff. Whatever. Common denominators. Yeah.
Trig identity.
Yeah, trig identities if you need to, yes. And I manipulate it, change it to another form, and then I evaluate it again until I get a number. And then last, it's not a bad idea to go ahead and graph that and see if your number makes sense when it comes to the graph. So this is the 3 different ways we can evaluate limits. Okay, so let's look at, and by the way, I've graphed them here for you. What is, and by the way, this says plus and minus. The plus and minus right there, this is from a particular textbook.
Does that indicate you're supposed to do
Both, but if you left off plus and minus, if it just said as x approaches 2, that would mean the exact same thing.
Yeah.
So the plus minus is like frivolous there. It's like extra, doing the extra. But the limit as x approaches 2 of 1 over x minus 2. Let's talk about this. So, clearly, based on the beginning of our class, doing the rational stuff,
The limit from the left.
I am going to have an asymptote at x equals 2, right?
Yes.
Like if you know nothing else about this problem, do you know that that's going to have a vertical asymptote? And you probably could also say it's either going to go like this or like this. Am I right? And you may have to kind of think about it before you can decide, is it like this or is it like this? Because I do too. I'm like, I think it's going to go, let me plug in a number. If you plugged in 0, you would get -1/2. So I know it's crossing the y-axis at -1/2. So that would tell me that it looks like this. Okay? Yeah. And the y-intercept, like always check the y-intercept. It's the easiest thing to do and find, and it kind of can give you a bearing, It's like using a map. Okay, what is the value, the y value of this function as we get closer and closer and closer to 2 from the left?
Negative infinity.
Very good. It's going to keep on keeping on forever and ever, amen. And it's going to negative infinity down there.
How do you write it? How would you write it if you consider both of them? Would you do like a bracket?
No, no. But let me, I'll come back to that, okay? Now let's talk about what is the value as x approaches 2 from the right.
Positive.
It is going to be positive infinity. Okay. From the left, it is negative infinity. From the right, it is positive infinity. Do those match?
No.
No, they do not. And also, did I get an actual number?
No.
No, it's more of a concept. That means that the limit does not exist. And has anybody seen Mean Girls? The limit does not exist. Is that why you were giggling?
Yeah.
Yeah, the limit does not exist. That is the actual answer to that question that the quiz bowl person asked her, was the limit of something like that. I can't remember the actual problem, but this person got it wrong because they said 2, or whatever. This person got it wrong, and then she's like sitting there, the limit does not exist, and flashes back to something her teacher did in class and all that good stuff.
She
So,
only saw it because she was looking at the guy in front of her.
yes.
She noticed it kind of like in her peripheral vision.
Yeah, that's
because it's all about boys on Mean Girls, right? Do what? You literally write does not exist. Does not exist. D-N-E. I'm sorry, does. He's like, if there's one, then what is it? No. It is does not exist. Okay, D-N-E does not exist.
More like one now that.
I know, now that you said that. Thanks a lot, Aiden. Okay. What about as x approaches 0 in this function?
positive infinity, positive infinity.
They do both go to positive infinity and positive infinity, but again, is that an actual
It's
value?
It's a concept.
Right. And so this does not exist. What about the limit as x approaches 0 of natural log of x?
Well, you've got negative infinity, and then you've got literally nothing.
Oh, it's from positive.
Okay, so technically if you
Oh, oops.
this says both. The limit as x approaches 0 from the left, I'm sorry, from the right, let's do from the right since I wrote that, of natural log of x would be negative infinity. Okay? The limit as x approaches 0 from the left,
Does not exist.
the function doesn't exist, so the limit definitely doesn't exist. So that's D-N-E. And so there is, it also does not exist if it just says as x approaches 0. Okay? So this one is a does not exist. What has to happen is the limit from the left has to match the limit from the right and be an actual value.
But what about piecewise functions?
We're going to talk about that right
I
now.
was gonna say, 'cause what about piecewise functions where there's a hole and then there's a,
There could be holes, there could be asymptotes, there could be all kinds of stuff.
well, take it like the one on
Uh-huh.
the next page.
Hold
where
on.
it's like two of them. In that case, it's just
That is what
plugging
I'm
in
doing
values,
next,
right?
isn't it? Yeah. Let me do that in a second. Well, let me talk about that in a second. John, what's your question?
Is it like bad if you get a D&E? Is like fine? Okay.
No, that's fine. Like some limits do not exist. Okay? And that's why in that quiz bowl, in that movie, they're all under this pressure because the question was, what is the limit of this? And like nobody wants to say does not exist. Like they want to find a value. Yeah, sometimes the limit does not exist. So, yeah.
So, for the natural log of x as it's a base on the left, is it does not exist because it's exponentially expanding in that direction?
Oh no, from the left means this way. And there is no graph of the natural log of x.
Rather than like following the graph.
Yeah, no, it just did not exist because natural log, all logs, have a limited domain, and it has to be greater than or equal to 0. I'm sorry, not or equal to, greater than 0. So basically down here is like, remember the behavior of rational functions, logarithm functions, square root functions, cube root functions, all those things kind of play into knowing whether it exists or not and what it actually is. Okay, so let's look at this one. Yeah. So it will have a limit as x approaches that value from the left, and it will have another limit as x approaches that value from the right. But if either one of those is infinity and not just like a number, like 7, then the general limit as x approaches that value would not exist. Good question again. Now, I don't want to What I'm basically spending the most time on are the issues, the functions with issues. Please remember that if you're doing the limit as x approaches 3 of, and I'm going to rewrite x to the negative 2 as 1 over x squared. I'm sorry, x squared, sorry. Then, don't forget, yes, there are issues with 1 over x squared, but this is just asking the limit as x approaches 3. And so what would that be?
9.
No,
1/9.
1/9. Very good. You just plug in that value, okay? The issue comes when you plug in that value and you get an indeterminate form. That's when all the headaches. And that's a lot of what I'm talking about today, the what ifs. But don't forget, sometimes you just have a function and it says, what's the limit as x approaches 10? Well, plug in 10 and it might give you a number. Yeah.
So that's how we simplified that one with the radical minus 3 on the bottom, because it would give you an indeterminate form in that form.
Correct. And so that's the best thing to do first. Camille?
So on that last panel with all the
Sure.
does not exist stuff, you can't figure that algebraically, can you? Because I tried that first one with the conjugate stuff. Obviously it's going to be infinity, but then you get
X squared.
1 over x minus 2, and what?
Yeah, no. Because really this is the simplest form of this function.
Oh, yeah.
If you were to do anything algebraic then it would muck it up big time, right? Yeah, algebraic nightmare. And so that's what I mean by if you can kind of remember the behavior of asymptotes, or the fact that, tangent, has asymptotes certain places. So if I do the limit of as x approaches pi over 2 of tangent of x, then that would be infinity from the left and negative infinity from the right. And so knowing all those behaviors that we've done all year long can help you when it comes to these crazy graphs like this. There's really nothing algebraically that would help me with these. I just kind of have to know what's going on.
So on the first one, does the limit not exist because there isn't an asymptote?
In general, when you are asked as x approaches a value and there is an asymptote there, then pretty much, no, the limit does not exist.
So long as it's a vertical asymptote.
Right. And so you can't say that about all the other creepy asymptote horizontal. Right. The limit has to be a y value, and this y value from this side is negative infinity. The y value from this side is positive infinity. And those A, I don't know what infinity is, and B, they're going completely different directions. So clearly the limit does not exist. They're not going to match.
Same deal with the B.
I can't. Yes, they both go to positive infinity. Yeah. So what number is that?
50.
Right?
Exactly.
Exactly. What is infinity?
It's a set.
If you can't state that the limit is 1/2 or 7 or negative 52 or 1 over 18, if you can't actually put a number, guess what?
It's 42.
No.
So what did you do with C?
Does not exist.
Look, see that function doesn't exist, right?
So the limit as x approaches 0 from the left does not exist. And the limit as x approaches 0 from the right goes to negative infinity. And so, the limit as x approaches 0 in general is just a nightmare on this one. So clearly it does not exist.
What?
So does it approach a certain number? No. So therefore the limit does not exist.
So why does that say the limit is negative infinity?
So the limit as x approaches 0 from the right is negative infinity.
Why?
Like,
An
why is
infinite
that?
limit- An infinite limit isn't a limit.
Correct. But, okay, so guys, the answer to the limit from a certain direction can be infinity, negative infinity, whatnot.
Okay.
But the overall limit as x approaches 0, it's either a number or it doesn't exist.
Okay.
Right.
That's
Yes. Uh-huh. Yep.
Is it like infinity plus 1 infinity?
Still, I don't know what that number is, so it is not a limit.
So how do limits work on the polar coordinate?
We'll get deeper into that as we go.
I think that that's just kind of interesting. They're actually
Yeah.
And also, how can you use limits to help find roots?
Yeah, there's a learning question.
Okay. So hold on a second, guys. Again, don't forget that sometimes you can just plug in the number and be fine,
Plug and
right?
chug.
Plug and chug. Now, let's do this one. If we plug and chug, what am I going to do?
0 over 0.
So analytically, this is going to be 0 over 0, and that's where you go, oh hell, I got to do something else, okay? And what do you see algebraically? I have x plus 4 times x minus 4 over x minus 4. So now, and okay, just looking at the original, if I'm not thinking about factoring, then I know I'm either going to have an asymptote or a hole in the graph, but I don't know which. When you factor, the fact that this and this cancel out or factor out, then we know this is going to have a what? This is going to have a hole.
So if it
Okay.
ends as a 0 over 0,
So this has a hole, and I cannot evaluate f of 4, okay? Because if I'm evaluating f of 4, I would get f of 4 would equal 0 over 0, bleh, an indeterminate form. But if I do an algebraic manipulation and cancel things out, then I can find the limit as x approaches 4 by just plugging this in. What would the limit equal? 8. If you were to graph this, it would be a straight line, literally the line y equals x plus 4, but it would have a hole in it. When x equals 4, and by the way, the hole would be at 4,8. Does that make sense? The limit would be like where that hole is. So this definitely is a straight line with a hole in it. But by golly, that straight line from the right, it is approaching 8, and from the left, it is approaching 8. As we get closer and closer to 4, this is approaching 8. And it would be from both sides, so therefore the limit is 8. Yes.
So that first one doesn't have a hole?
No, this one I do know that this has an asymptote. This is graph B
So
up above.
is the asymptote just y equals
X equals 0, good catch on that. And this is literally the graph of B, but on the slide before this. And it is 1 over x squared. I just kind of know it looks like that. I'm like directing band for you. There, a drum major. Think of a drum major when you do 1 over x squared. And did that speak to a few of you? Anyway, there is an asymptote there, not a hole.
So what's the 1 over 9?
this was not asking for the limit as x approaches 0. This one was asking for the limit as x approaches
So
3.
that's just the point on the graph?
Yeah, exactly.
3/1/9, I guess?
Yeah,
Alright.
very good. Yes, the point on this graph is at 3 1/9. This one has a hole at 4 whatever, and we do the limit in order to figure out the whatever.
For the 1 over x squared, do you not do like, since it's just x to 3, that would be both sides, right? That you're
Yeah.
looking at? So why doesn't the 1 over here go to infinity?
It does. But this right here is asking as x approaches 3, not the asymptote. Let me, sorry, it's right here. This was this was asking as x approaches 0, and whoa, there's an asymptote. But the next part was asking as x approaches 3. And see, that would be down here where it's damn close to the x-axis.
Okay, sorry. So
And
it's
it-
not, like, it's not these two anymore, it's like this one.
Right. Mm-hmm. Yep. It's just honing in on a certain x value. Zooming in on a certain x value, if you will. So, all right.
I was the point where it got developed enough that it could be pretty easily taught in high schools.
Okay, guys. This right here
Trig identity time.
is, all the different things that you can do algebraically, okay? Now, all of these are indeterminate forms. If I were to plug in 3 to this, I'm almost certain, well,
You would get 0 over 0.
is the top 0 9 minus 12 plus 3? Yeah, that'd be 0 over 0. If I plugged in pi over 2, the tangent of pi over 2 is
It's
is actually undefined
undefined
over
over 0.
0, which is, again, an indeterminate form. I mean, like, wait, that is like, you're not, yeah. That one means you're not going only to Hades, but you're going to Hades and Purgatory for the rest of the time. Yeah. And if you plug in 4 here, you'd get 0 over 0.
The physics realm.
So, again, guess what I'm going to do with this one?
Play algebra.
Oh, factor, yeah.
Yeah, you factor it out.
I was 3
X minus 3x plus 4.
Yep.
And then you get x minus 1 over x plus 4.
So,
2 sub.
So you guys, this algebraic, this rational function, I can just factor, and clearly that factors out, and that means I'm going to have a hole. And that also means that when I plug in 3 to here, the limit as x approaches 3 of this would be 3 minus 1 is 2, and 3 plus 4 is 7. That is the limit as x approaches 3. Now, technically, it is going to be a rational function with an asymptote at -4, and there is going to be a hole at 3 2/7 is the y value. So real close to the x-axis. And that's more details than you actually need. Okay, so then let's get to this guy. Clearly, there's an issue. If I plug in pi over 2, it's undefined and 0. Ah, okay, so let's see.
Actually, you can get them even easier if you do sine x over.
That's what he was saying.
Well, I don't believe you. Let's do it.
I was going to say sine x 1 over cosine x sine x times 1 over cosine x over 1 over cosine x, and you just get sine x.
And that is what I'm doing here. So this is sine of x over cosine of x times cosine of x over 1.
Yeah.
So this is just sine of x. So what is the limit as x approaches pi over 2
1.
of sine x? That is going to be 1. It's just the value, just plug in. What is sine of pi over 2? That would be positive 1.
That means there's just a hole in this graph at 1.
No.
That means the limit.
Well, yes.
There can be
Yes.
asymptote.
There
This is a
is a hole in the graph at pi over 2, comma 1.
yeah.
Right. When you say at 1, that's the y value. You actually want to give the x value to be able to locate where it is. You see what I'm saying? So that threw me off. But by the way, if this had been the limit as x approaches 0, then, and I did all this work, sine of 0 is 0. If you get that the limit is 0, that is fine algebraically. If you get that the limit equals 0, the limit is equal to 0. The issue is when the limit is equal to 0 over 0. That's when our world explodes, kind of. And we've already done one very similar to this, although, it made sense on that first example that I rationalized the denominator, like that's what we did. But here, like, what the heck am I going to do? I am going to multiply by the conjugate on top and bottom, but I'm going to do the conjugate of the numerator. Yeah, square root of x plus 2. And you're like, but Miss White, it's like backwards of what we were taught. Well, you were trying to achieve what you're in the past. What we were trying to achieve is, I don't want a radical in the bottom. Well, now the only thing I don't want is 0 on the bottom.
Yeah.
So if I can manipulate this in whatever fashion, so that when I plug in 4 for x, I will not get 0 in the denominator, then I'm going to do it. So as backwards as it feels, the top will be x minus 4. Okay. And the bottom I am not going to distribute because, can you see it? Can you smell it? That's going to cancel out. This has a hole, and you evaluate it as the limit as x approaches 4 of 1 over the square root of x plus 2.
1/4.
And the square root of 4 is 2. 1 over 2 plus 2 would be 1 over 4. So this is how you take something that at first you look at it and it's indeterminate. What can I do? Okay? Certain things from long ago. Certain things from long ago, I cannot do anything algebraically. But if you can do something algebraically, you do it. And then it all works out. Hunky-dory. Right? Okay. Serenity now. Right?
It's just asking how. So you can literally just write the method, like you can say simplified graph. So, yeah, I'm not going to work
through these fully because I actually want to look at some graphs here in a second. But I would get common denominators. And surely once I do that, if I were to plug in one, I'd get common denominators, and then I think something will cancel once I do that, and then work it from there. This one, holy crap, does not factor. So,
Let's graph it. Yeah, you can graph it and then factor with decimal.
You could do
Can you say like,
Actually-
take out a plus, can you separate the 5 into plus 4 plus 1 and then factor it?
this does not factor, and ain't nothing gonna cancel out. So would anybody like to take a wild guess as to what this would look like if we graphed it?
Probably has to go to.
Oh, yeah, it might have complex roots.
Maybe like,
You're missing it.
Well, it's gonna have it, it's gonna be a vertical asymptote.
There's going to be a vertical asymptote at 2. And then what is the other asymptote going to be?
Is it like?
Oh yeah, that's a slant asymptote.
That is a slant asymptote. The degree of the top is one more than the degree of the bottom.
It's like 3 axes.
Hey guys, this graph is not drawn to scale. Okay? I'm literally just drawing a slant asymptote. This graph is either going to look like this and this, or it's going to look like this and this. Okay? So whether we're looking at the red or the black, what is happening at the asymptote? We're either doing this,
the dogs on the one side.
there you go, or we're doing, what did I just do? This. Okay, yeah. And either way, what would be the case as the limit approaches that asymptote?
It was not a negative infinity.
Right. Positive infinity, negative infinity, it does not exist. So the limit of this one does not exist.
And then the next one you can actually.
What about the slant?
There's like, if it approaches the 2 asymptote, that's right.
H squared plus 2AH over.
Oh wait, I don't see y'all on Tuesday. I will talk about this on Wednesday. By the way, do what?
What?
What'd you say?
Wait.
It looks like a what?
Maybe just realized.
It is.
Okay.
This is the definition of a derivative.
So that gets like simplified to look.
And by the way, yeah.
Stuff for
Oh yeah, it is.
Okay, wow. That's good then. You guys, y'all listen. Y'all listen. This is a slope formula. This is, the y value minus the y value over an x value minus an x value. The distance between those two x values is referred to as h, which is what is used in the definition of a derivative. And plugging in those values gives you the f of x value, the y value. And this is actually slope, which is synonymous with derivative and gradient and all the things. Yeah.
What's the, this is kind of just a far off question. What is the integral of like the dx?
that is the distance between each little interval. Remember we talked about slicing it into rectangles? That is literally the width of the rectangles that you're slicing it into. And I will get to that.
Now let's do a triple interval.
Okay, yes. Hey guys, y'all look, sit down and don't draw another toilet.
I didn't draw a toilet.
You can't stop.
That was
The toilet man.
I was about to draw derives of position, velocity, derivative.
I am hesitant. I actually do you want to do analytical or do you want to do a graph? Okay, so at first, analytically, this is asking for the limit as x approaches 2 of a piecewise function. And what that means is, for values greater than or equal to 2, I would get the f of x value, the y value, by plugging it into x squared minus 4. For x values that are less than 2, I would plug it into this.
Oh, so it's just like a hop thing.
It might do a hop thing. Okay? So this is the way I do it. I'm going to do it analytically and graphically. Plug into, what do you get? So if I plug in 2 right there, y equals 0. Okay? If I plug in 2 right there, y equals negative 1. Well, guess what is going to happen at this graph? Like you just said, since they are not equal, there's going to be a hop there. Is that what you said? Yeah. And so here's graphically what's going on. For everything less than 2, this is a straight line, and it is starting down here and going up. Okay? But not at that value of 2. The x squared minus 4 is only to the right of that. So if I go down 4 and I go, and I go like that, it looks, so it's a straight line and part of a parabola. Please look at me. This is actually kind of painful right now. But anyway, does the line hook up with the parabola?
No.
Or is it like slightly separated from the parabola? It is. And we know that analytically by plugging in the values there. And I know there's going to be a hop there. Okay, what is the limit as x approaches 2 from the left?
Negative 1.
What is the limit as x approaches 2 from the right?
0.
And are those two equal to each other?
No.
Then the limit does not exist. Okay? So,
Just minus 1 and 0. That would make so much more sense.
what'd you say?
Limit. Could it be like minus 1 and 0?
No. The limit, okay, so let's say this. The limit as x approaches 2 from the left, then that equals negative 1. The limit as x approaches 2 from the right of f of x is 0. Therefore, the limit as x approaches 2 in general does not exist. Does not exist. Those have to match and be an actual value for us to have a value for the limit. Okay? So that is how I approach, that's how I approach piecewise functions. Okay? Now, by the way, this is for later because you are graphing a function that you are only given the limits for.
Oh, yeah.
That's tough. And what's even harder, my gosh, like I still kind of like get nervous teaching it, is to draw the graph of a function given the graph of its derivative. What is actually, I get lost doing that. I'm just going to be totally honest with you.
Just knows what he's doing every single
That's
time.
what he just like loves.
Right.
And he
Well,
loves making
for
it-
that, you kind of have to do reverse your calculus things, like the sine of x.
Is it
for
possible to
cycle
find the average slope of the graph of an asymptote?
Say again?
Is it possible to find the average slope of a section of graph of the asymptote?
Of a section of,
A graph including the asymptote?
no.
No.
No. You can do stuff like before the asymptote or after the asymptote, but not. Yeah. All right, guys. Look up here. And yes,
something that's intuitive.
hey guys, your assignment is playing around with some graphs on Delta Math, and it's called Intro to Limits. Okay, and to be honest with you, if you
Yucky.
y'all stop. If you mess up on these, just read it and do the next problem. And that is part of getting used to it. All these questions that you're having that you may or may not ask me out loud, it will eventually answer it. So, okay, this is asking for the limit as x approaches -5.
Negative.
Oh, wait, is that what it really asked for?
Yes.
Oh,
-5.
yeah, the limit as x approaches -5. What is it?
-5.
Yeah, the y value when x is -5 is -5. So actually, that one, it's like you're just putting the y value.
Wait, so you can put in infinity and negative infinity?
Very good if it asks from a certain direction.
It's just the fact that
Negative
like
Four.
sort of insanity.
Actually, I want to do another one.
Yeah.
You guys, come on. So this would be a piecewise function from hell. Okay. Admittedly. Okay. What is the limit as x approaches -4? Wait a second.
There's a negative. There's a limit.
From the left.
Well, both from the left and the right were
So from the left,
-3.
y'all look.
That's the whole.
Yeah.
From the left, it is approaching -3. Actually, from the right, it would also be approaching -3.
Yeah.
So actually, if that negative wasn't even there, meaning the from the left thing, if this just said the limit as x approaches -4, even, what would the answer be? -3. Because it is doing the same on both sides. Now, if we were doing the limit as x approaches -1, y'all look
Which way are we
up
going?
here. The limit as x approaches -1 from the left is 1. The limit as x approaches -1 from the right is -3. Since they are not equal, the limit as x approaches -1 period does not exist.
So the limit of x approaches 4 on this is -2, right?
Correct. The limit does exist
Because it's not
here,
the actual point.
and it's equal to -2. Very good.
Random black dot for it.
Oh, that's
That means that is the value
That's the
of,
value. It's not the limit.
that is the value when you plug in 4 but everything greater than or less than 4, excuse me, follows this function. Yeah.
Oh, yeah. I forgot about that.
Yeah.
The notation gives you.
Mess around with those, and do me a favor, mess around with these graphs sometime this long weekend, okay? Because I'm going to build on this information on Wednesday, okay?
When are we going over law 2000?
Yeah, what were you going to ask? Oh, stop it. No, you know I'm recording. That's why he's doing this. I'm so sorry.